Hey, welcome back for another lesson on intro to terrain systems in Houdini. Today we're going to talk a little bit about some geometry post-processing that we can do. We're going to talk a little bit about doing our scatter system so we can start putting additional things on. That could be rocks, it could be plants. In this case, I'm going to throw a couple plants on my scene. And I'm just looking at my image, and I've got a little like crazy bedhead from being up all night. Oh, just crazy. Houdini will do that to you. It's funny, like even in this, just the act of putting something up on YouTube. This is an intro beginner lesson. My perfectionism kind of kicks in of wanting like, oh, it's got to be like movie perfect. And this is really just a beginning intro class, so I have to remember that. I'm a few days late here getting this up, so I apologize. All right, so let's go ahead and jump right in and see what we've got. All right, so let's jump in here. We've got this scene that I've kind of set up, and it's designed to kind of give us a few challenges with a lot of really vertical faces. We've talked about the struggles of that in the past. We talked about using triplanar projections. There's stuff that we could do to the geometry itself to help bring out some details. And it's always that back and forth of, do I do this in the geo, which can get really heavy? Do I do this with displacement? Shaders can get really crazy complex. So it really depends on the situation and what you're doing. Sometimes you want that to be geometry based. Sometimes you want that to be shader and displacement based. So we'll just kind of dig in and look here. All right. So let's just jump in. I've got my scene set up here. I'm going to just run you through my scene here, my setup for my terrain. All right. So I'm going to jump inside here. So here's kind of my hero level detailed out geo that's got some post processing on it. You know, if we take a look at what comes out of this is what comes out of our heightfield terrain. Right? And you can see like, oh, there's some interesting shapes in there, but this would be crazy reliant on displacement in order to bring out some of these areas. And so, all right, I'm going to take you through building this real quick, because why not? We've built enough of these that I'm not going to build it from scratch. Start with a height field. I'm adding some noise, remapping that noise. Here's some easy little vex. If you want something that you don't have to hit this stupid compute range button, right? As great as that is, this takes a look at the intrinsic bounds, which are the lowest and the highest of the data within the height field, and allows you to use that. So no matter what happens, if this changes, it will always remap properly. So I know that whenever I change things, if I have a whole bunch of remaps and things like that, and I have to go through and hit those compute buttons, I don't like that. So I try to do this as much as possible. So we generate some noise, and then I'm just using a mask that I drew. I know I say that I hate that, and I do, but I just used a draw mask node and drew a shape on there. You blur it, I inverted it, and then we go ahead and we multiply that against that noise pattern. So it gives me kind of this little, mountain in the middle. Great. Then I'm using height field distort, right? We all know what that does. It kind of moves it in the X and the Z directions. And then I used a height field mask expand node. You can say, but that's for masks. This is really just a height field blur node, which has a whole bunch of operations. It has blur, box, blur, expand, shrink, and sharpen. And you can apply that to any of your height fields. You could apply this to the debris field. You could apply it to anything. So in this case, I'm applying it to the height, and I'm using expand. And so it just takes it and kind of boxes out that and gives me some interesting shapes. Now, those are all really square, right? It's like maybe in Tron that would be useful. Not as much here. So then I'm using a distort node, right? We've done that before, distort by noise, and we can see now it breaks that up a little bit, and we get some nice shapes in there. Still building, right? So we come down through here, and what I wanted to do was I wanted to have Oh, I don't even think I ended up using that. I don't think I did. Yeah, I did this whole thing. I was going to do some noise patterns anyway, and then I cleared it. So I'm glad I left that in there. All right, so here's a noise pattern, just a different one, a different pattern, and it gives this kind of shape. And then I'm using this height field distort by layer, and my control layer is height. And so what that does is it gives some more additional, it's just another way to add shapes into our scene. So that gives me some more of these cliffs. You know, some of this isn't super awesome. I know I fought with some of these like really sharp ridge lines, but we'll leave them in. It's fine. Now I do a mask height field mask by feature. So in this, we've been through all of this. I'm using slope to get the tops, right? And then I'm using height. So that way I can just kind of isolate the top of my flat areas. I'm doing a blur of that, and I'm adding some noise, okay, based on that blurred mask. So I'm just adding a little more detail back on top. I'm doing that same gag, right? So this is that expand node, so we're expanding the height field, so kind of just pushing that out. Again, none of this is required. This is just exploring, trying to find shapes that I like when it's purely procedural, right? I'm not art directing this in the sense of this is exactly where I want to think. I'm building like a little system that kind of gives me shapes I want. So clearing that mask out. So now I'm taking and I'm actually running it through a height field road, and it does this kind of cool stuff. But I lost a lot of the kind of the brick shape kind of stuff. And so to show you that you don't necessarily have to use this, what I did was then I took this layer and I did a height field layer where I brought back in and I swapped out the height of my pre-simulated height field and brought in all the other channels. So you can see now I got back that kind of blockiness, right? But now I have all this great stuff that's run on top of it. So I've got my flow fields and or not my flow fields, sorry, my debris fields, my water, my sediment, bringing those in. Now, one thing that happened when I did this is you can see that the debris no longer feels associated with the underlying geometry, because normally that fills up, right? When we look at the debris, it fills that with debris. So in this case, I wanted to be able to mask out where I copied back in the old height data. So in this case, I took my debris and I copied it into the mask. So now I have a mask for where my debris is. Then I invert that. Then I'm expanding it a little bit, right? So this is all on the mask, expanding the mask, blurring the mask, and then I'm just doing a remap there to get the shape that I want, just to shape it a little bit, and I'll show you kind of what that does. So without that remap. So what it does here is you can see, right, that this is like just like a sticker, and now this is actually the debris. So let's look at when I add this little bit of change. Oh, it did hardly anything. That's funny because everything was so sharp anyway. I know at 2 in the morning it seemed like it was doing a lot of cool stuff. So you could probably just leave that off. But anyway, the idea was I was trying to just round out some of these corners a little bit, you know, in these areas. Well, it did what it gave me what I want. So now I've got my piled up debris. I've got my original kind of shape there. So then we come back in and it's a lot of that same stuff. So now it's masked by feature, right? We're getting those cliffs. We copy that into the slope, right? And then I'm taking height here and I'm blurring it. I'm sharpening the height field. And then I'm masking my feature. What I'm doing here is I'm trying to isolate these ridge lines, because when you start doing stuff on the geometry, where I add these features on there, as you push and pull that geo, sometimes those edges will collapse, right? You'll get like interpenetration in these little canyons and on these ridge lines. So I'm just creating a mask to control that. So then this is all just doing that. And then this height field layer, I'm copying in the mask, right? So if we look here, there's my mask. I've already copied it over to be slope. Now I'm copying it back in as a mask. And the reason I use this is because I actually modified the height field, right? So if we look, this height field got all squishy and soft because I'm blurring it and sharpening it, trying to get rid of some features to help get the mask that I want. So I don't want to change my height field, I'm just trying to make this mask. So I'll copy back in that mask. All right, that's what this layer does. Allows us to bring in this from the second input layers that we want to replace. We can also add, subtract, all these things. So then the next thing I'm doing is going back to the mask again. So we can see I'm expanding it, I'm blurring it, I'm remapping it. I don't think I actually did. Oh, I just changed the fall off on that so it's not so linear. Another sharpen after that. And then we inverted that mask, and then we copy this. Oh, sorry. Then we use the height field mask by feature, and this is set to multiply. And what we're doing is we're catching just the flattest areas and saying I don't want it in there. So we multiplied that against that, so it zeroes those out. We blurred it or expanded it again, blurred it some more. Right? Just kind of trying to find the thing, and then at this point, we copy that into a new attribute called edge exclude. We've been through all this already. Then I'm doing a height field resample node. You notice I'm not changing the resolution scale. I'm just using this to filter everything a little bit. So if we were to look at, the water, we're looking at, kind of these chunky shapes that we're getting, and then I hit the resample. It just smooths everything out just a little bit, just enough. Then I'm going into a height field blur. I'm blurring the debris on this one, the debris pass. Now I'm sharpening the height just a little bit. So now I'm actually modifying my height field to get something a little bit better. And then I'm converting it. So I convert to my mesh. So there you go. One trick that I recently learned is, this kind of stuff really sucks. This kind of uneven polygons, and so if you just come in and remesh it, you'll get a more equal distribution of polygons. So this takes a minute. It's a little bit of a slow process, but that'll help with UVing, it'll help with displacement, all those things. So you see we get a much better look. And one of the critical things here is to look at your target edge size. The default, I think, is 0.2. On something this large, it'll crash your scene. So bump this up, and work your way down slowly, right? The smaller this number, the tighter the polygons. You can also use adaptive, and that will put more polygons in the places where it needs it and less polygons where it's flat. But in this case, we want a fairly even distribution. So this is a really heavy mesh, right? So this is heavy. So ideally we would get to a point where we could clean some of that up. And you can see here I still have some nasty stuff in there. Like I would want to clean that out better, but we'll leave it for now. So then in this case, because I'm going to put in geometric, I really should pull this off of here. Because I'm going to go in and put in more data, right? Like I'm going to sculpt this. I'm subdividing again. All right, so we can see now I have even more points to work with. Woohoo! All right, smooths out some of those little areas in there. I'm making sure that it has normals. All right, putting a normal node on there. Then I'm blurring those normals with an attribute blur. So you can see here it's the normal is the attribute. Blur iterations are 50. And then I'm coming into my attribute. I'm doing this in two stages because one, I'm making a pattern that I want to be able to blur that attribute a little bit. So if we come in here, we'll look and see that I've got this voroni pattern that I've created. And then I'm going to use this to shift things within my the build that I'm making, the detail adding that I'm doing. So let's look inside here what this is. So I'm taking my position, and you can see I'm multiplying it down. This is that same gag with noise that it's you know, I could either change the frequency here, but I chose to do it here. So I'm taking and I'm making 3D noise. That's a controller, so I can control the scale. And then I'm adding it back to itself. The reason for that is if I ignore this, you'll see that that Voronoi pattern becomes very straight. And now it has nice irregularity, right? I don't want it to be so straight. So we're kind of tricking it. And then we generate the pattern off of this new, like, turbulated position. We can look at what this looks like, right? If we were to put this into position, right? This is essentially what we did. We shrunk it down and we added, like, you know, a bumpiness to it, a noise pattern. Okay, and then from that we're generating this Voronoi pattern. So cut that off. So I used the Voronoi noise. It makes this pattern. Now, if you look at the Voronoi noise as it comes out, it, you know, it creates. That's strange that it. It's a noise pattern, and what I wanted was like a float value. So I just took this, and you know, we can look at the different kind of patterns that this makes, right? So this is more maybe your standard kind of Voronoi that you would expect, which it, you know, has a fall off to it. But I wanted like cells. I wanted things to shift. If you have graduated values, right? So you have from 0 to 1. When you use that to transform things texturally, you'll get stretching and pulling. And so I wanted something that that was, you know, like cellular. So, you know, each piece is its own kind of thing. So using the random, this allows us to generate this kind of float value instead of a Voronoi pattern, which is, you know, positional based. It's a 3-dimensional noise that comes out of this, right? There's a different one that I could have used. This one I didn't like. It's too much. I like the cellular nature of the first one, so this is too. It might have been interesting. I decided to go with this. So the last thing I do is I'm putting a bind export node on there. So bind export, and then I give it a name here, and I just named it Voronoi. That gives me an attribute that now exists on the points, right? So there's my Voronoi. I also have it in the color, right? I outputted it as color as well. So the reason for that is now I can come in and I can take my Voronoi attribute, and using an attribute blur, I can blur this so I can soften it. So if we come in here and we look at this Voronoi, you can see that it went from being this hard cell pattern to now being softer. So there's different times that I'll be using one, and that's why I stashed it in the color as well. So now I'm going to go inside this second attribute VOP. We'll come in here and you'll see that there's a little bit more going on. A lot of it's the same. So here's where I'm pulling in my color, right? And I only need one float out of that. And this is where I'm taking my position, and I'm just multiplying it down. I'm using a constant here. I could have used a multiply constant node. I could put a parameter in here if I wanted to expose this up. And then now I'm just shifting some things around. So by using this pattern like I was talking about, let's make sure we're viewing this. And I'm going to just take my output here and I'm going to break this for a second. Right? Well, let me make note of what I was connecting to what. Right, that's my P and that's color. All right, cool. So we'll come back here and we'll use our output to kind of chase down what we're doing. So, you know, if we look at at this for position. Right, so we've shrunk it down. Now you'll see that if we look at this, it moved it, right? So it's just like a transport there. So if we were to look at this mix now, we can see that I've got this kind of cells of it reaching out. That's probably more extreme than I needed, but so now I have a noise pattern coming out, right? So this is our turbulent noise. I'm going to put this into color so we can see this. Fascinating. What? Oh, this pattern is just so big. Let's do this off of. You can see it very slightly. It's kind of red over here and blue over here. Really, it comes down to like, let's go like this. We'll say frequency is 1 and 1 and 1. All right, so there you can see more of that noise pattern in there. So what I'm trying to do is, again, I'm trying to give myself different patterns, different noise patterns, right, to help with changing where these eventual outputs are gonna the shapes that it's going to make, right? By creating these offsets, when you feed this into the position of this, right? So let's look at the difference in position here. Instead of color, we'll put it under position. All right, so this is one of them, and then this is the other. So they're going to get different. They're going to get different results from this turbulent noise, because this turbulent noise is looking at where that point's position is in three-dimensional space. And what we've done here is essentially moved where those positions are in three-dimensional space before calculating the turbulent noise. Right? So if we were to look at this, this is going to look different. Oh, that just blew up like crazy. It's stuff everywhere. I'm surprised this even worked. Okay, so now let's go back to just our regular model so we can kind of see how this is playing out. Because remember that even when we change shapes of everything, it knows based on the points what the data is. So regardless of when we move things, don't move things, the points know, which in each one of these branches there's the same number of points. And so when we merge them back together, when we put something in as color, even after we've changed its position, we're only modifying one thing on it. So it's a pretty cool setup. So let's take a look at this. So this is where put this into color so we can kind of see this. So what I've done here is I've got 3 different noise patterns coming into this. We've got one going into the red, the green, and the blue. So that way we can kind of see what's happening. So you can see here where those edges of those Voronoi patterns are, right? If we were to undo those offsets, all these horizontal lines would kind of be like one long line running through the whole thing. But by creating that offset with those Voronoi patterns, it allowed me to have those not line up, so you can get these kind of cool, offset, staggered rock shapes. So this right now would be applying this to the entirety of my model. But what I wanted to be able to do is I wanted to be able to say only have it happen on the slope, and then also, right? So let's look at that. So we'll come here. Right, so we can see that that's just going to limit it to the slope. But then I was having trouble with some of these, hard edges kind of ballooning and getting a lot of the geometry twisting back over on itself. So in that case, that's why I created this edge exclude attribute, right? That was the one where we went through and we were trying to find just those sharp edges and deep creases. And so then when we multiply, well, let's do this. Let's take this guy off. Right? Oh, that is the right thing. There, you can see that just right there where I'm remapping this down, so it's just cutting down the amount by half. So it's still doing the displacement, but just by half. All right, so we're going to come back here, and now we're going to take a look at our new geometry. And I'm going to go ahead and we'll step out one level, and let's look at it with no color. And if we don't redo the normals, you look at that and you're like, oh, it didn't do anything. That's because we only changed point positions and we have to recalculate our normals after that. And you can see here where we have some of these problems with the mesh kind of getting really, really trashed. So, but you can see how much we're getting additional detail. So if we were to look at this as a model compared to where we started, right, which would be this, right? That's a big improvement as far as our vertical faces go. So we start to get some really interesting rock detail. And again, I go back and forth because I can do this very thing in the shader. It's the same ideas, right? This attribute VOP is really just like shading on geometry. The difference is with geometry based, you can only, you're limited by your resolution. If we turned off the subdivision here and let this run, right, we lose a lot of that detail. That's why we're cranking that subdivision, so that way we can get the detail that we want out of the geometry. So this is where we kind of go back and forth over where should we be doing this. Should we do this on the geo? Should we do this in the shader? I am more inclined to do this in the shader than I am on the geometry. There's something cool about being able to see the geo and tumble around it, and rendering that can feel like it takes a long time, because it does if you're displacing. So it's a back and forth of really trying to figure out which is the right way. So we can see some of those Voronoi edges still, right, where there's some differences there. That's where these lines are coming in from that Voronoi pattern that we made. So now I want to fix some of these kind of gross geometry things that I created, because that's a big part of procedural geometry. You're making stuff and you have to go in and clean up. So in this case, I'm using a mask by feature. And when we look at this, if I hit the I button and I come over and I click on mask, right, that's what this is generating, a mask. This is just like mask by feature on a height field, but it's only on, it runs on geometry. The interface is different. We have less options than we do in the height field. So sometimes it might be better to do it in the height field, but it just depends. In this case, we couldn't, because this is geo. We've already converted it. So I've turned off basically everything except for the calculate ambient occlusion. I've turned up the blurring iterations. I increased the ray distance. I think I lowered the cone angle because I'm trying to access, kind of these parts here that are getting, all chewed up, right? So once I've done that, I've got two different smoothing that I'm running, so I can then smooth out my geometry. So if we select this, we can see that the attribute it's smoothing is P. The strength of my smooth under uniform is 10. And let's turn off the mask here so we can kind of see what's going on. And then on this one, I have a second smooth, because I was finding that some things were getting kind of more chewed up than others, although I could see I could probably have gone further. You probably need the normals on this to really see what it's doing, because you can see there. Let's actually crank this one. Let's go to 15. And then we'll put a normal on it. right? So that helps you to see, because without the normals, it just looks the same. So we still got a few little kind of not awesome spots, and I would, if this became a problem like in the shot, I would go in and clean that up, but for now I'm just going to call that probably okay. Let's go back to 10 on this. Yeah, so we'll leave that at 10. And so let's look at the one that does it by 2. The one that does it by 2 keeps just a little more sense of what we had. Maybe this should be 4. Just to clean up just a little bit more. That looks good. So the 10 is a little higher than I want. The 4 kind of fixes some of these really hot spots. So what I did was I used a wrangle, and we could do this with a VOP as well, but wrangle is so fast. I came in here and I defined, I pulled the position of my second input, right? So this second input here, I created a vector called P2, right? I'm creating an information container. And in that information container, I'm putting the position of the second input point, right? Because remember, the point numbers are the same. So I'm able to take point, and 1 means that's the index of the input, right? This is input 0, 1, 2, and 3. So this is saying pull this index, right? Index 1. Find the position, and I want you to find the position of the current point number that I'm referencing over of this point, right? Because the point numbers are the same. So it looks that up, stores it in this P2, and then I take my position, which is at P, that's the variable, the attribute, and I tell it to be equal, and then I use lerp, which is linear interpolation, between my current position of the points coming into 0 and this position that I brought in from the second input, and then I'm using the mask attribute that we created with the mask by feature to tell it when to use points coming in from 0 and when to use points coming in from 1. And the result of that ends up being this. There was a bigger change before I changed some of this stuff. So let's take this first one and we'll make it 1. Let's make this 20. So if we were to look at this before, right, it gives us, this was the model that we generated, and now we come in and we take a look at it after we've brought those two things together. And so we've been able to smooth out certain trouble areas and then keep our other areas having the detail that we want versus, you know, that and that. Oh, well, we have to look at this with normals, right? So that would be, you know, where we're trying to smooth out some of those bad areas. And we can see that we're keeping just a little bit of that detail, right? And then that's my output geometry. So now I have these two different pieces of geo, and we kind of test against those. So that's how I go through kind of adding additional detail based on slope, you know, kind of attack these vertical faces and add some more rock texture. There's not a right or wrong here. This is that challenge of Houdini, that you can really approach this in any way that you see fit, where you can go at it with it from the geometry side, you can go at it from the shading side. So in this case, I use the geometry. All right, so now let's talk about how do I put some, let's scatter some stuff on this, because that's where it gets really fun. There's several ways that we can go about scattering. So one of the tools that I really like is the heightfield scatter node. But let's look at a couple different things. So first, I want to actually scatter on that geo, right? let's assume that this is what I want to scatter on, right? Because we've made some adjustments to the geometry, so we want this to be the thing that receives where our stuff grows on to ensure that it grows from the right spot. So the first node that we could use is we could use I think it's called geometry, it's called scatter and align. So just like the mask by feature, where there's a height field version and then there's a geometry version, there's this kind of scatter tool that is similar on both sides. So here's our scatter. This is this creates the point cloud that you want. We can go through, and this will pick up attributes from our surface. You can see it's picking up all of our surface attributes. So with this selected, which is all these points, we can see we have all the things on there: bedrock, height, mask. We have all the things that we wanted. So there's a slope here. That was our cliffs. So I could, right off the bat, I could put down a group by expression node. And excuse me, I could then say where its slope is greater than 0, run on the points, and there you go. So now what this is doing is it's saying, all right, I'm going to take everything based on the attribute that's on the points, right? Based on the slope. It's going to look at this and say, oh, whenever I'm not equal to 0, I'm going to put you in this group. And we can call this group, we'll call it remove. And now I'm going to add a second rule to this. And I'll say remove. And I'm not going to replace, I'm going to say intersect, let's say union with existing. All right, that's going to add the two together. And with this one, I'm going to say at p.y, which is our position in y, our height, is less than 2. Right? Oh, sorry, that should be replaced. This should be union. So now I've been able to, I just want to kind of keep things in and tucked around the mountains. So now I've been able to kind of capture all of that. And now I can come in and say, great, blast, remove. And so now we can see I will have things that will grow in these areas. Now I can continue to do this where I could add another rule, and this one I could say subtract from existing, and we'll say remove, and I'm going to say at debris is greater than 0. Oh. We have debris on here, right? We don't. Oh, there it is, right there. Oh, well, that kind of got everything. So let's say greater than 2. All right? So if we turn this off, we can see that, we're kind of getting into those debris areas. Oh, I actually want this. No, not intersect. Oh yeah, I want to union because I don't want it there. So I'm just basically kind of pulling out all the areas, like the debris area. I don't want it to grow these things. I want that to be like piles of rock and all that stuff versus trees and grass. So now when we look at this, this becomes my setup. And then I could do one more, and I'm going to, with this one, I'm going to say subtract from existing. We'll say remove, and I'm going to say at p.y is greater than 200. How tall does this thing get? Not 200. That might be because I just deleted them off. Let's say, sorry, not subtract. This is union. and this is greater than, we'll say 100. So now I've got, you know, the top of my peak. I'm not going to have anything. Let's turn this on like this. All right, so we can kind of see where this is going to grow. Okay. So now to visualize this and get an idea, I'm going to put down a copy to points. The first thing I'm going to do is I'm going to turn on this pack and instance, because it'll, if you have a ton of geometry, if you don't turn this on, it's going to actually do the copying to points each piece of geometry. So you have a copy of that geometry in memory, which will crash your file. So I'm going to plug in my points here to my second input, and then I'm just going to use a box for my first input. And there we can see there's all my boxes, and let's make these bigger. All right. So, you know, right away I can see, you know, these are, you know, they're all kind of following the terrain. And if let's do a different, let's do platonic. And let's do a tetrahedron. There we go. And I want this I'm going to move this up to the ground. I don't like it being down through the ground plane. And the way I'm going to do this, I'm going to say bounding box, and I'm going to say the surface is 0. That's my incoming myself, essentially. And then the float type, this is a string that we want right here, and we want this to be D underscore Y min, and we want to subtract this. I don't need the quotes. That's strange. We're going to cut that. And I'm just going to do that with a transform after the fact. There we go. I'm not sure why I didn't like that, but this gives me that. Now I can also take this and I can say, great, I'm going to make this 5, maybe 3, and we'll make its Y scale, we'll just double that, make it taller. And let's do our transform first. All right, now let's look at our copy to points, and we can see we've got all these fun little guys. And to me, I want these to represent trees, right? And it's a little silly to have my tree growing at an angle. And trees can do that, but most trees, you know, try to grow straight up. They don't really, they'll start growing like this, and then they'll turn and go straight up because they're chasing the light. And the greatest intensity of that light is going to be at noonday, because when you're in a grouping of trees, that, you know, you're always going to be able to get that which is right above you. So there's a couple of things within our scatter align node that will allow us to make modifications to this. So one of those things is if we come to orientation and alignment, we can, the initial geometry mapping, let's see, that's all fine. I don't ever use this node, so I apologize. I'm having to remember a little bit. It's not that. There's this blend with Y. So now you can see it's pointed straight up, right? Instead of using the normal. Now you can come in and like just ease in some of that original normal, right? I probably would use almost none at all. The other thing that you can use is, I believe, this rotation. Yeah, so this is the way that I would actually do it, is because then you get a little bit more of a randomization off of that. So you can see these are all kind of randomly scattering. So I usually do something like 3 to 5 degrees of random rotation in the up to give me something that feels a a little more natural. Maybe we'll do something like that. So it just breaks that up just a little bit. But now when we look at the top, we can see that these are also all facing the exact same way. So if we were to put a color on this, right? So if we were to come here and say color, and we'll make it this red color, make it orange. And then I'm going to put another color node down, and I'm just going to tell it pick a singular. Oh, I don't want these to be point colors. I want this to be primitive colors. And this one I'm going to make bright blue. There you go. So now we can see that they're all facing the exact same way. And that never happens in nature, right? A great way to take your model and make it work for you is to have it just rotate it, you know, and it'll feel like a different thing if it's turned. So with this, you can come here to this rotation around the normal, and you know, we can just start setting this, and you know, coming up to 360, you're going to get, you know, complete randomization here, and so everything's going to be different. So that gives you variety as to the shape of those, of how those line up. So offset angle, it looks like you can go in and use an attribute, and you can, you know, offset those. So if you want to do something that's a little more control instead of this kind of random, you could use a particular map to drive that and have certain things facing certain ways. That might be helpful for rocks or things like that that you need to have them facing a certain direction. But that's the basis of this node. You can layer these up and make, you know, different points for different objects, right? So like if we had a different platonic that represented something else. So I'm going to do this, and we'll use the Utah teapot. And now I would need to really have a second kind of scatter that I would do. So I'm just going to go ahead and grab this, copy and paste. Wow, it's being slow to paste. So I'm going to come back to my first one here, and we're going to reduce these number of trees, and then we're going to stick a bunch of these Utah teapots in here. So coming back here, I'm going to change my coverage to 1.5, and this is going to reduce the number of trees. Oh, I can go even further and go to 0.5. Right, so it's just a percentage. You can also change this by density, number of points. So you could set an explicit number of points. Sometimes that's helpful if you're trying to really control how many points you're generating for memory reasons. Oh, and then lastly, we can change our scale on this. It's always good to put a little randomization of scale. All right, so it gives us some bigger, some smaller. Now we'll take our second one, and we're going to do the same thing. I'm just going to reduce this to 3.5, 0.75, 1.5. And now I'm going to merge this. Well, I'm not going to merge it. We'll do a second copy to points. And there's our teapots, right? And then we can merge these two together. Right, so this would be, you know, you just start layering up all the different scatter systems that you want in order to, you know, have your vegetation system, right? Because some of it's going to be grasses, some of it's going to be shrubs, some of it's going to be trees. Now the reality is with this, everything's interpenetrating, right? There's no awareness here for how it scatters, I don't believe, as far as being able to take its, give it a size to consider as it scatters it on there. So now, taking this into render, I actually would just merge these points and send this out to Solaris, because I would do the instancing at Solaris, not here, right? And we're gonna show that in this next step. So this is kind of geometry. Well, maybe I should show this. All right, so we're going to show. So what I'm going to do is I'm going to take each one of these, and I'm going to come out here, and I'm going to actually make output for this, and this will be our pyramid. This is our teapot. And then we would use an object merge. And there we go. So the nice thing about this is then you have this as an asset. We'll bring these into our Solaris context and then be able to do it. So again, I'm going to set these up as points, and I would like these to go into one instancer. So I'm going to put down a name attribute for these points. So I'm going to put a name on these, and I'm actually going to change this attribute from name to tag, because that's what the other one is going to generate, and I'll show you that why that matters. And so this one is going to be pyramid, and this one is going to be teapot, and then I'm just going to put an output on each one of these. Right, I already have an output elsewhere, so I had to change that index. And I'm going to call this points underscore pyramid points underscore teapot. And then this also needs its index changed. Okay, so now really I don't need any of this stuff. This was just to help me kind of visualize what was happening. And you don't have to do this. You could do this all after you set this up in Solaris, right? So we'll delete this so we don't have that as a crutch, and then we'll use Solaris to kind of finish this out. So I'm going to jump back all the way up to my stage. This is currently already using an instancing system. I'm going to go ahead and just take that off. I'm actually going to go ahead and remove my materials from this for now, so we'll just speed up kind of this whole process, help this to be a little quicker. All right, so I need to, first off, I need to bring in those assets, which are my teapot and my pyramid. So I'm going to use a, I'll use a scene import node. We can also use a sop import if we wanted to. So in this case, I'm going to come up here, and my object network for this is going to be where I currently am. So I'm going to say dot slash obj net 1. Oh, I don't think it likes that dot slash. This has to be an actual hard path. Kind of lame. Let's see if it'll let me do that. Oh, I just typed it wrong. Object net 1. Great. And then we'll click this. For that, we want it to be... Do I just give it the name? Pyramid? Aha! It worked. Woohoo! So it came in as pyramid, mesh 0. That's great. I'm going to copy and paste this, and this one's going to be teapot, and I was really inconsistent, and I had one start with a capital and one without, but that's okay. So now that we've got this, we're going to go ahead, and I'm just going to move this over because I don't want to look at this anymore. We're going to bring in an instancer. So we're going to put down an instancer, and let's just go ahead and start hooking stuff up. So I'm going to click to view this, and you can see it's erroring. That's because I believe we're not giving it any points yet. So it says, I don't know what you want me to do. So it's set to internal sop. For right now, we're going to set this to external sop. And we're just going to go grab from our scatter, our out points pyramid, and say accept. So this is not resolving. So we're just, for kicks and giggles, we're just going to tell it to use the entire stage because we weren't specifying anything yet, right? So we said use entire stage. So now that, Brian, you can see already, look, our pyramids came in, they're all rotated exactly how we set them up. It's that easy. Like, we've got that all set. Now we can pin this if we wanted to and go into our scatter, right? And on our pyramids, scatter and align, we could come in and start modifying this, right? And say, great, maybe we want this to be 1.5, and then check that out. It changed. Now, here's the thing that stinks about that. I just changed the scale, and it totally changed the seed of everything. Not that's a bug. That's not my favorite. That's probably why I don't use this system. So, all right. But you can see how we're kind of tied in now, and we can see it, you know, in the context. We could have this being rendered at the moment, you know, via Karma or Karma XPU. Now you could make another instancer that is going to be for our teapots, but I want to do it all in one. It's more efficient. So I'm going to put down a merge node. I'm going to merge these two things in. And so now you see we have our pyramid and our teapot. And this is still only grabbing our pyramid. Oh, it's not actually. It's on every point, it's putting the pyramid and the teapot, which is not what we want. So I'm going to turn off this entire second type prototype. And from random, I'm going to change this to be name attribute. And remember, we changed that to be tag. So I'm going to set that to be tag. Now, this is still not happy about the prototype. So let's just give it those two things. Invalid prototype name, scatter align 1. Well, this is why I don't do it this way. I don't love what's happening here. Okay, there's those friends. This should be using it's pulling in both prototypes, but we're having a problem with, so let's do this. Let's change from external to internal SOP. The reason for that is we're going to jump in and we have two sets of points that we want to bring in. So we're just going to use an object merge, and I'm going to grab my points from my pyramid. I'll just add a second one here, and I'm going to grab points from my teapot. And now we have points. That should have, so if we do this though, if we say use entire stage as the prototype, it does do that. It puts them all on every point. That's not what we want. This is supposed to use, so if we look at this, we should have a tag. There's our, our tag is named scatterline and scatterline 2. Let's go back That is why. So your scatter. This is why. Because my class is primitive, but it needs to be points. Right? So it's always good to look and make sure that you get the result that you expect. So there's my, now I have teapot and pyramid. Great. Problem solved. So now we can come back here and turn off this entire stage as prototype, and there we're getting the same result. That's what I would expect, which is fantastic. Okay. So now let's look at the other tool set that we could use to do this. So I'm going to come back into our object network, into our scatter, and instead of these two kind of outputs, I'm going to use the current heightfield project system, or heightfield scatter system. Now I'm pulling in my modified geometry, right? This is our cliff. And I want to be able to use the heightfield scatter node. So if I use heightfield scatter and I plug this into my geometry, I believe this won't work. It shouldn't work. I'll laugh if it does. It's taking an awful long time. I wonder if this is creating a height field out of this under the hood. Hitting escape. All right. So here's what I do in order to be able to work with current geometry. And sometimes you'll be getting geometry from other departments, and it's not a height field. And I want to scatter it and build a system on it. So what I'll do is I'll take this and I'll say, great, I'll use a height field. So in this case, there's my height field. I'll make it the size and placement of my geometry, and then I just use a height field project. I don't get as much obviously details in here, but this is as close as I'm going to get. And I can always turn up the resolution or turn down the spacing here to increase resolution. But you can see there it didn't give me that much, right? And it definitely makes things a little slower. So, but we'll leave it like that. And so now I can start with a scatter. So I've already kind of got this set up. I'm just going to move this over to the side, and let's just start over. All right, so I'm going to plug in my height field and my geo that I want to create. So here's my height field that I've got. I'll leave it at 2. I like it to be a little lighter weight. Now from here, I'm going to put down a height field scatter node. We'll just take a look at what that does. When we plug this in, huzzah, we got points and they're kind of just everywhere. This has a lot more stuff in it than the other does. They're like the same things, but the UIs are totally different. So it can be confusing as you jump back and forth. At the top, we have the scatter method, which lets us choose how we want to scatter it by. In this case, it's coverage by using mask layer. This is by density using mask layer, total point count using mask layer, and then per point count using source points. What this one is you could actually feed in points and it'll scatter objects around those points. Like if you had a tree and you always wanted it to grow something around the base of that tree, you could use this to do that. And you'll see as we layer these up. I'm going to stay with coverage right now, and we'll let this kind of go as it is. So the first thing that I like to do is I like to start figuring out my mask of where I want things to grow. Which is kind of what we did a little bit here. This was essentially masking by using attributes. In this case, I'm going to make masks. So I'm going to use a height field mask by feature. And I'm just going to go ahead and invert this. Oh, sorry, no, I want it to be, yes, I want it like this. Okay, so this is going to be the first thing I do. Now the reality is I don't want any of these like really slopey faces, so let's get rid of that. And that looks great. So if I plug this in now to the second input of my scatter node, Cool, my points are only growing there. Now I'm gonna just kind of mix in a few other things here. I'm gonna do mask by height. I'm gonna compute range, and I'm going to say, get rid of this. This should be, oh, it's because it's inverting. All right, so instead of inverting, I'm going to invert my ramp. There we go. Because now I can essentially come in and say, awesome, this is where I want my stuff to grow. The cool thing about this is we then end up with the same kind of techniques that we could use for our our system. Like if I don't like how smooth that edge is and I want to break that up, I can do a height field noise. Right? I can add some noise to this, and maybe I'm gonna lower this down to something more like that. And then if I plug this in now, we'll see I get a very different result. Okay? So I can take this and adjust this a little bit more, right? Element size down. Something like that, just to kind of break up, create some holes in it. And then I'll do a height field layer node, right? Again, this will allow me to bring in my height field, apply my mask to it. Okay, so we can see there that I'm just replacing the mask. And really this doesn't even matter, to be honest with you, because this is just like everything else. It's just the mask. It doesn't care about the height or anything else like that. So it creates kind of this breakup, which is really cool. The reason I did this though is now I can go back in and I can kind of rerun this mask by feature. Instead of replacing, I can do a subtract, I can do a maximum, a blend, I can do a difference, right? I'm going to do a multiply, and so then you can see I kind of keep my original mask and nothing can get outside of that, but I just have broken up the edges a little bit, right? So if we look at, what this was to what this is, right? We've gotten rid of some stuff, some yucky things. And so now I can plug this in, and ta-da, awesome. Now the reality is here I can also now take this and I can say, maybe on my height field ramp here, I want to get rid of the higher elevation stuff. Right? Now that's a really hard line. I could do this as a second break off again and do our whole height field noise. We've done this before where you're turbulating that, changing what the result is, and then mixing that back in. But for now we're gonna call this good. So for my trees here, we'll call this the pyramid. I really want this to be, I don't need this type of coverage, so I'm going to change this to like 0.05 and get a lot less. So let's go ahead and just look at what this is going to look like. We can do the same thing. Instead of needing to do like the copy to points, I can actually just plug in, actually let's not do that. You can plug in right here your geometry and see it, but let's do it, well, I'll show you. Object merge, I'm going to go get my pyramid. I'll do a second one here so we're ready, and this will be our teapot. So there you go. So there's my system with my pyramids in it. And you can see it's got all the same things that we had with the scatter where it's following the terrain. So let's kind of move through this. So this is the scattering. This controls how tightly packed they are and how much they'll intersect with each other. You can see here that we are intersecting with ourself a lot. And you can set this outer radius and fall off to control how much it'll allow those to kind of blend into each other. This uniform distribution is the same thing as our scale. I think. Now that I said that, yes. All right, so if I were to take this and make this 3, you're going to suddenly get some that are really big. Now, the interesting thing about this is you saw how everything changed with that scale. I guess the other one did too. Now that I said that, I think this is behaving the way it's supposed to. Oh, goodness. What it's doing is when you increase this uniform scale, based on these numbers get multiplied by the scale of that object. So it's saying nothing can be within a certain distance. So as we change those, it's going to change how it allows the packing to happen. It's going to be aware of how big the instance of that object is. That way you can make sure that things aren't penetrating each other. Relaxation is how the points scatter in regards to each other. I don't typically change any of this. Now down here is where we start to kind of play with some stuff. So matching direction of the slope means that the Z of the object will always face kind of downslope. Right? So if we turn that off, we can see now everything is facing the exact same direction. Right? And then if we turn off this, we now see, well, really everything is the exact same. So usually I'll turn those two things off. Unless, like for example, if these were fallen trees, you know, I would want these always to kind of lay down. Like, let's try that. Let's do a tube, and let's make its axis the z-axis. Right, so you can see here how the tube is kind of always pointing down the slope, which is pretty cool, pretty convenient. So, you know, I would use this if I'm laying a bunch of things laying down. Now we can see here that the other part of this that we probably want to turn back on is match normals with terrain, because now really that's really going to follow. Right? That's a useful tool, very useful tool. But that's not what we're doing, right? So if we plug this in, I'm going to turn these back off. I'm going to randomize my up by about 3 degrees, maybe 5 degrees, so I get a little bit of difference between those two. And then I'm going to randomize my yaw. I'm just going to max this out, which is 180. And so now we get, you know, maximum between those. So those are the difference there. I'm going to go ahead and I'm going to reduce this even more to 0.1 for my coverage, so I have a little less. Let's do 2.5. That looks good. So now comes the cool kind of factor of this heightfield scatter is I'm going to go ahead and say heightfield scatter, and I'm going to merge in another system here, right? The first thing that this is going to do, and we'll call this one teapot, is when it creates these, it's going to attempt to create these. I want to use my mask there. It's going to attempt to avoid any point tag, right? In this case, if we see here, we come look and we have a point tag here that is pyramid, and so this is going to make these, but it's going to try to make these and have them not be inside our pyramids. Now look what happened there. This is why I don't set it up this way. There's a default in this where it defines its pieces. Like you could give it a whole bunch of just pieces merged together, like all of your different objects. If they're single geometry objects, you can put them in like one merge, and then it'll just randomly select those from those different points, different pieces. You can also do it based on an attribute. You can create an attribute on something and it'll pick those. But in this case, we're just going to use single piece. Now we can see this isn't perfect, that we do still have things that are intersecting. And this comes down to our teapots are even intersecting a little bit. Oh, they're pretty close. I think because they're about a value of 1. This value here, this outer radius really is 1 meter, right? So if our teapot, right, if we were to view this, is about 1 meter, right? So this is radius, so this is a little bigger than what this is, because this one's, oh no, that's right. Our radius is a little more than 1, right? Our diameter is a little more than 2, right? Almost 2.5. And then our circumference would be around. So radius is what we care about. So when we come back and look at this, if I were to increase my radius a little bit, you'll see that those all separate. So I'll take my radius here and I'll say, great, let's make you 1.25. Right? And so that feels a little closer. Right? You can see here how they're kind of stacking up. Now, the reality is there's a longer distance here. I probably should have looked at what that length is to ensure that they never intersect at all, you know, but we'll call this good. Now, it is intersecting with our tree, and it's probably because our tree radius, right, our pyramid radius is not set adequately enough, or outer radius on that. That looks, let's look at it. Oh yeah, for sure. Check that out. So our radius on this is, I'm guessing at its maximum, looks to be about 2.5. So we'll take our pyramid and our outer radius, let's make that 2.5. So we definitely got less trees based on that. Let's change this back to 1. But we're still not getting proper separation. So by turning off self-overlap, this is allowing these to intersect. We don't want that. Masking cutoff, iterations, removal rate, stepping rate. This should be catching that tag. Again, I don't normally mess with this. You'll see as you increase that, you get kind of better, you know, the points stay out of each other a little bit more. Let's turn on, just for kicks and giggles with this, we'll say that this is like grass. So this is probably still not going to, well, I'll just turn these both off. So for the randomize up, I'm going to do a little bit more extreme, something like 15 degrees. We'll keep it on the terrain, so, but I can still, even with that, I can still use these randomizations. And with this, let's make this the full 180, so we'll get, you know, random turning of all those teapots. So one thing we can do, let's kind of go through this. These three are all essentially the same thing, right? This is just how it determines the point count. This last one means it's going to use source points, so you're going to give it a tag, right? In order for it to determine where it wants to grow. It's going to try to grow around those points. Then it has a range, right? So this is the, I think the distribution that it will grow at. So like if we, let's simplify this. Right, so we're cutting off how far away from the tree it can grow. This inner source radius, let's make this 2. All right, so now this is using that kind of 2.5, and you can see here, we'll make this bigger. So around each one of these trees, these points, these pyramids, we're getting growth, right? We're getting these things kind of scattering from around that. And then the fall off is how much they can kind of penetrate in. You know, we can take this and make this right, to kind of push that stuff out. This way is cool for building up, you know, little kind of ecosystems. It really comes down to like a weird math kind of thing that you're having to think about how all of these different things affect each other and how they're affected by the one coming in, right? So if we change this input, it's going to change what this happens here. So it's this kind of cascading effect of settings, right? So the cool thing about this is wherever you get a, you know, a tree, you could have grass, you know, always growing around that. It just really depends on what you want to do. I'm going to go back to coverage by mask layer, right? So that way it's kind of really filling in that whole area. And then let's see if we can get this to... Yeah, you can see how they're, you know, they're definitely interpenetrating a ton. That's just on the relaxation. What I would probably do is after the fact, if this was really bothering me, I would create a little system on top of this that will allow me to then go and kind of clean that up. I would take one point and say, based on proximity to this point, find its neighbors, delete those neighbors, and get those out. So for right now, we're just going to call this, we're happy with this, and we're going to send this on to Solaris. So in this case, we're going to put down an output node, and I'm going to call this points heightfield scatter, and we need this to have its own index number, and we can now just send this on out. Now the reality is this has more than just points. We can see there's packed geos, there's volumes, and we really don't want any of that stuff. So I'm going to put down a delete node, and I'm going to just tell it to delete this at name. Sorry. Click on both of those, heightfield and mask. So that now deleted our volumes, right? But we still have our packed geos that we want to get rid of. And so we're going to say, how did I delete this before? Oh, and so before I didn't care to have this connected. I just built the points and I took it right over. This is one of the things is why, because if you're building here and you're trying to look at this, I prefer to just see it in my USD context. So I'll usually just disconnect these, because if we delete the packed geos are going to leave behind a point that's in a different position, and I'll show you that, right? So let's do this. Let's say delete. We'll do a second delete here. And we're going to say delete non-selected, right? And that's going to delete everything. But we're going to say keep points, right? So there's points. But if you look, those points are up off the ground when they should be down on the geometry. And that's because what this is sending out is our packed geo versus the actual scatter points. So one of the things that we can do is, there's two different ways that we can deal with this, right? Let's just get rid of that. One is we can come in here and I believe there's an option to click off. No, this isn't what we want. We'll just do this. So we'll get rid of that. And now you can see we have all of our points and they should be on the ground. do something here that we can compare. And we're going to say delete non-selected, keep points. And then we're going to disconnect this here. Sorry this is messy. Just trying to illustrate the point here. So if we look at these points to these points, right, you can see clearly that they move, right? So the problem with this is that then when you instance, these are all going to be floating. So don't want to do that. We just know that we want to do it this way. It's just a better way of generating it. So now let's go look at we're going to come back out here. We're going to go ahead and we're going to drop down another instancer. And we're going to plug this in. And we're going to go ahead and tell this that we want the prototypes to be teapot and pyramid. And we're going to say external sop. We're going to go and get our heightfield scatter points. And there we go. So now we can see that those picked up. That is strange. That doesn't look right. That's because options, not random. We want this to be name attribute, and we want this to be tag. There we go. So that now is doing what we had before. Okay. So the cool thing about this way, is it's just a little more managed. I guess that really it's all the same, right? Like either way, this worked fine. This was the first one that we generated. Here's the second one that we generated. And then once we have this, we can just merge this in with our mountain that we're already building. And there's our stuff. So this is how you build scattering. And so then the cool thing about this is you can start with really simple assets like spheres, cards, cones, pyramids, and essentially build out really low-res versions of what you want and start scattering this out. Because you can see here, we're starting to reach some memory limits. So Houdini is actively switching these to boxes, to bounding boxes to save on display memory. But then we can start really building up a really cool scene here. And building really complex scattering systems. And these assets that scatter on there, we can replace them with whatever. So you just go in and change either the tag name on the points, or you can go in and replace what's the innards of that. So like if you're thinking ahead and planning, instead of calling it pyramid and teapot, you would know the name of the asset that you want this to be: pine tree, fir tree, wild grass, shrub, elderberry, whatever that is, and you just follow those naming conventions. So we can come down here, we can go to our camera, and we can switch to XPU. Let that render for a second. I have no idea how long this lecture has been going, so. Okay, so there you go. So you have a render. You can, bring these in now. I can show you really quickly. Let's load in one asset. I'll just do a quick replacement here. So I'm going to go ahead and do an asset reference. This is something I've built in the past. So I'm going to just browse to this file. Let's see here. So there should be. So here are a bunch of trees that I've made. So in this case, I'm going to use, I can't remember which one's better there. We'll use conifer, and I'm just going to go ahead and grab this conifer USD, and we'll take a look at what this looks like. So there's my tree right there. Nice low-res proxy of that. This actually has different variants on this, so I can set. So we'll look down, and we'll go over this as we get more into Let's do the explore variants. I've never used this node. So that's this is just showing you. I have it where it's just using a curve, like a widened out curve, to show the tree itself. So it's very lightweight in the viewport, but still gives you kind of the idea of the shape. Let's do this. I'm going to actually use the set viewport, set variant. Sorry. All right. So in this, we can go here and look at the final, render. Right, so there's that geo, right? But this has a version where you can get up much closer to that. And so instead of being like this kind of chunky stuff, let's take a look. We can come in here and there's a geo variant. The variant names are high, low. So let's look at high. So there you go. So this is the high of this. And I believe when you do this, you also have to set the... I built these a while ago. You're also going to set the material to high as well. That way you get the proper, one is card based, so it's got a bunch of card rendering stuff on it. And the other one is a general texture over the whole thing. So for both of these, I'm going to set these to be low. And now we can go ahead and instead of asset reference, let's call this, we'll call this, what was the asset name? I think it was conifer. I don't even think that's spelled right. Conifer, might be, I can't spell anyway. So conifer, and so let's go ahead and take a look again at our scene here. We'll go back to our camera. I'm going to pin this, and I'm just going to merge this in with my prototypes. And so now I'm going to have, if we select this under my prototypes, I have teapot, conifer, and pyramid. So if I come into my object network here and go to my scatter, and this is calling pyramid right here, which if we look, that's the tag is being generated with the $OS, right? So it's pulling pyramid. So if I just name this conifer, what we're going to see is that that should get replaced with my conifer. It should. It's got an issue here. Skipping instance name conifer, invalid prototype. Conifer. It's that easy, folks. It's that easy. Just do this. That's a little strange. That should have picked up and been okay. Let's look at our information that's coming out here. And let's look at our tags. And there's conifer. No prototypes found. Oh, yeah. This is a yuck. So let's do this and let it pull everything in because we're kind of hand specifying that. And clearly we see my scale here is really not awesome. My trees are giant, but there, I was able to swap in those trees. So part of this would be making sure that when you're building your temp geo that you're using something that's going to be the size that you're actually going to load in. But you can see how quickly and easily that you can switch out assets here. We'll continue to go into this and talk about how do we then use attributes on the points to set our variants. So we can then load in a bunch of assets that have these different material and level of detail variants that we can then set So as we get away from camera, we're using this lower resolution version, and then when we get closer to camera, we're using something that's higher resolution. So let's go ahead and just for one last thing, we'll hit Karma Render and see what we get. We can see here that it went through, did the compile, and we're within the RAM usage of our graphics card, which is great. So at this distance, those trees work really well. This is far better than using the high on this, that like every little clump of pine needles is a polygon. This is a much lower resolution. We get nice density of those trees. So you can see we have variation in scale. Everywhere that there's trees, we've got kind of this stuff on the bottom, and this starts to look pretty cool as far as our scene goes. I think this tree is probably really big. This is like probably a 20 meter tall tree, 15 meter tall tree, which is very tall. So, I could always control that just by changing the P scale and shrinking that down and controlling that. So, but that's how simple it is to start building, and you can see how much it adds to have, trees and then something around that, and you can then utilize this for your mid-range to create kind of texture breakup, and then at distance, obviously, my trees would go further in distance than my grasses do. My grasses would switch to a texture solution versus having those actually be scattered. So as you can tell from my hair, it's been a wild one. We got through some cool scatter stuff. We touched a little bit on that geometry sculpting. We can cover that more in future weeks as we talk about how to continue to take this more towards photoreal. But planning and being able to design out your environment and think about your vegetation, how that all comes together is going to change how you texture everything as well, right? Because you're going to be determining based on the details that you get out of these scatter systems. They're going to cover up parts, so you don't need as much texture detail as you might think in certain areas, or you might need more than you thought in others. Thanks for coming and thanks for watching. I hope you had fun with this lesson, and we'll see you next time.